Adam. Let's do some curve sketching. The first problem is graph f of x equals 3x squared plus 2x plus 5 all over x squared plus 2x plus 1. So the first step is just to simplify the rational expression, and we get this. So then we look for the domain. The domain would be minus infinity to negative 1 and negative 1 to infinity, because the denominator can't be 0. The intercepts 0, 5, that's the x-intercept, and using the quadratic formula, you get the roots of the numerator are not real, so there are no y-intercepts. Symmetry, no symmetry. Asymptotes, no horizontal. For vertical, there is, because the denominator can be 0, x equals minus 1 is a vertical asymptote. For slant asymptotes, well, because the highest degree of the numerator is 1 more than the highest degree of the denominator, it's going to be a slant asymptote, and using long division, we get that it's y equals 3x minus 6. Now for intervals of increase or decrease, well, we find f prime of x, and then using this, we look for when f prime of x is greater than 0 and when it's less than 0. And using calculations, we get the intervals below. Next, for maxima and minima, we get the critical points, and we figure out that the local max is at negative 1 minus root 11 over 3, and the minimum is at negative 1 plus root 11 over 3. There are no absolute maxima or minima. For concavity and points of inflection, we find f prime prime of x, and from this we figure out that it's concave up when f prime prime of x is greater than 0, and concave down on negative infinity, comma, negative 1. There are no inflection points because f prime prime of x can never equal 0. And finally, for graphing, you just graph everything in order. You first graph the intercepts, we graph the asymptotes, we find where it's increasing or decreasing, we find maxima and minima, and we graph concavity, and that should give us a very accurate diagram. Okay, so that's it for this problem. Now the next problem, f of x equals 2 to the sine x power. How do we solve this? Well, we just follow the same steps. First find domain, and the domain's just all real numbers. For intercepts, there's no y-intercept because any exponential does not have a y-intercept. And x-intercept, just plug in 0, get 0, 1. For symmetry, it's periodic with period 2 pi because sine x is periodic with 2 pi. So we can just graph the graph on 0, 2 pi, and that should give us, we can just translate it over. For asymptotes, no asymptote. Increasing and decreasing, we do the same steps. We find f prime, find where it's increasing by setting f prime to be greater than 0, decreasing when f prime is less than 0, and we get the following intervals. Next, for maximum and minima, critical points are when f prime of x equals 0, and you just find them. They're going to be pi over 2, 3 pi over 2. We test the endpoints as well, 0, 2 pi. And what we get is that after testing everything and comparing, we get the absolute max is pi over 2, 2, and the absolute min is 3 pi over 2, half. For concavity and points of inflection, we're going to get f prime prime of x, and from this we look at when it's greater than 0 and when it's less than 0. It's concave down on 0.54, 0.6, and concave up on 0, 0.54 and 2.6, 2 pi. Points of inflection are just when x equals 0.54 and x equals 2.6, and from this we get the two inflection points. Now graphing it, it's just doing the same thing. Graph the intercepts, notice the symmetry, a graph where it's increasing and decreasing, graph the maximum and minima, and graph the concavity, and that should give you a very accurate diagram.